Hey everybody, welcome to 1.2, which is growth and decay models. So here is our first example. An automobile depreciates. So when I say depreciate, that means it loses value as it gets older. Suppose that a particular automobile loses 1/5 of its value each year. Write a recursive formula to find the value of this car when it is 6 years old if it cost $23,999 when it was new. So the first thing we want to know is, where does this thing start? If we're talking about answering our question, write a recursive formula. So we need to know, where does it start? So it says if it was new, that means it would be year 0. So we can start off with saying u sub 0 equals, and what did it start off costing? It started off costing $23,999, right? And so now we'd want to say at any value, u sub n is going to equal something with u sub n minus 1. Now, are we adding or subtracting the same amount of value every year? No, because it loses 1/5. So we know it's losing. It's losing 1/5. So this is kind of important, that it loses 1/5. So it loses 1/5 of its value. So if it loses 1/5, that means it keeps 4/5 of its value, right? So the car gets to keep 4/5 of its value, which is the same as 80%, which is 0.80. Okay, so we get to keep this. So every year it gets older, it keeps 80% of whatever it was at the previous year. So what we can do is we can actually take 0.8 or 4/5 and multiply that by u sub n minus 1. Now, since this number is less than 1 but greater than 0, when I multiply it by the previous number, I should get a smaller number, right? So, as long as this number is more than 1. So, as long as we look at this, let's figure out when this car was 6 years old. So what I did was I went to my calculator and I just typed in 23,999 times 4/5, and I got this number, times 0.8, because I didn't want to write 4/5, it's the same thing. I kept going. So what's nice about this is that it's just easy to type in times 0.8, times 0.8, times 0.8, right? And I can just keep on going. But what this doesn't do is this doesn't keep track of exactly how many years it's been, right? If I look back, I say 1, 2, 3, 4, and then I have to go back up. And so it's easy to miscount and be off by one number. So a slightly easier way to do this is just to use the calculator and use some brackets and parentheses, which will keep track of everything. So the first number is 0, keeps track of the months, and the second number, 23,999, will keep track of the year. So that's like u sub 0. U sub 0, here's what happens, right? So now what we're going to do is I'm just going to type this all in. So for the sake of this, I'm going to pause it and watch what happens. And ta-da, there it is. So what this says is take the answer 1, the first answer we have in the previous line, right, and add 1 to it, just like a recursive sequence. And this says answer 2, take the previous one and multiply it by 0.8. So then when we hit enter, there is, after year 1, that's how much the car is worth. Year 2, that's how much the car is worth. Year 3, and year 4, and then year 5. Okay, so I think we have to go to year 6, right? So let's just see. What do we have to go to? Find the value of the car when it is 6 years old. So how much is the car when it's 6 years old? $6,291.19. So we have the car is worth we said, what was it, 6,900 or 6,291. Sign 6291 and 19 cents. We could say the car is worth that after 6 years. All right. One thing that people will make some mistakes on sometimes is they say it loses its 1/5 of its value, so they just take 1/5 and multiply that, and that would be how much money is taken off every year. But if we just think about this for a second and say if it loses 1/5, it keeps 4/5, it's a lot easier just to be able to multiply and be done. All right, so there is example A. Here are some vocabulary terms that you need to know. So when we talk about decay, it's a sequence that decreases. So we're talking about a decaying sequence. It's a sequence that decreases. One way to remember that is they both start with the same letter. So things that decrease and decay are examples of them. Car values, height of a basketball. If you have a loan, when you're paying off the loan, the amount of money you owe decreases. All right. When we're talking about growth, that's when it's increasing. So your investments, if you put money into your bank, you will get a growth. All right. Simple interest, that is the percentage paid on the principal over a period of time. What the heck is principal? Well, that is the initial balance. What amount of money did you start with is called principal, and simple interest would be the percentage paid on just the principal over a period of time. Okay, compound interest is something we're going to look at a little bit more closely, and that's the interest received on the principal and the previous interest. So let's say you have like $1,000, and at the end of a quarter, you get like 5%. So 5% of $1,000 gets added on, which would be, well, it's a good amount of money, right? Well, I think so. $50 is a pretty good amount of money. So then what would happen is now you have $1,050, and the next quarter you get 5% of that, and then the next quarter you get 5% of that. So it grows, and then you get money on the interest that you already got. So compound interest, that's how money in the bank works. If you keep your money in the bank, it just goes up, and it goes up, and all the money that's in there just keeps on increasing. All right, so it's not just the money that you initially put in, it's all the money that you have in. All right, so here is example B. Gloria deposits $2,000 into a bank. So deposit, again, means you put money in. Withdrawal is when you take the money out. So Gloria deposits, puts in $2,000 into a bank that pays 7% annual interest compounded annually. So that just tells you how often does the bank say, okay, we're going to check to see how much money you have in the bank, and then we'll give it to you. We'll give you the interest. Okay? So this means the bank pays her 7% of her account balance as interest at the end of each year, and she leaves the original amount and the interest in the account. When will the original deposit double its value? So we're looking for double. We're saying, when is that going to be $4,000, right? So we're looking for, when is it going to be $4,000? So we could do a recursive routine. Let's say U sub 0, because it says when we put it in, it's not a month, it's not a year, it's just the beginning time, is $2,000, right? And since it's compounded annually, each one of these numbers is going to be 1 year. So if we want to find the next year, we would want to take the previous year, and we have to multiply it by something. Well, she gets 7% of the money that she already has, but she also gets to keep all of her account balance that she has, right? She gets to keep the original amount and the interest, all right? So not only does she get 7%, she also gets 100% of the original amount. So she gets to keep all 2,000 plus 7%. So she gets to keep 100% plus 7%. So that would give her a total of 107%. So that means if we take 107% and multiply it by the 2,000, that's how much money she'll have. So can we write 107% as a decimal? 1.07. So we're going to multiply that by U sub n minus 1. All right? So how long until that will double in value? This time we're going to use the calculator, but I'm not going to do this routine because I think it might just be easier to keep track. So we're going to say 2,000 is how much she starts with, right? So that is year 0 times 1.07. So this is year number 1. So she got $140 just for keeping that money in the bank. So we're going to multiply that by 1.07 for year 2. All right, take that times 1.07 for year 3. Take that times 1.07 for year 4. Take that times 1.07 for year 5. Times 1.07 for year 6. Times 1.07 for year 7. Times 1.07 for year 8. Times 1.07 for year 9. Times 1.07 for year 10. And times 1.07 for year 11. All right, so we got 11. That was a lot for me to keep track of. I had to say those numbers out loud so I wouldn't forget. So this may not have been the best strategy if I had to do more, but we got to 11 years. So when will the original deposit double in value? It will double in 11 years, and she will have $4,209.70. All right, so there you go. There are your 2 examples and some definitions.